All right, hello everybody. Welcome back to the Doctors In podcast. I'm Dr. Nadia Saba, and this is our special series, What Plants Crave, where I'm talking to indoor and greenhouse growers about the plants they grow and how they got to where they are now. My guest today is Melanie Yelton, former director of plant science at Plenty and now an independent CEA consultant. Before working at Plenty, she was vice president of research for LumiGrow, an LED lighting company that worked with growers and universities to study the use of LEDs in controlled environment agriculture, and really a company that was at the forefront of LED adoption across the industry. And before all of that, Melanie worked as a lecturer and scientist at Stanford for 25 years, where she researched the fundamentals of plant signaling and taught some pretty interesting courses, including biotechnology, a new field, I imagine, at the time. Basically, Melanie understands plants from their microbiology to their macrophysiology, making her a force in the industry as we try to figure out how to manage plant responses and control plant growth, quality, and the various responses we're targeting and touting as CEA growers and professionals. Melanie, it's so great to have you on the What Plants Crave podcast. Thanks for being here and in person. This is so exciting and a rare occurrence. So yeah, thank you for making the trip to Sacramento.
Yeah, thank you, Nadia. This is really wonderful to be here in your offices, see plants growing in your offices. You're not just talking about it, you're actually doing it. And I just live down the road in San Francisco, so it's easy for me to come up to Sacramento. Thanks for having me.
Yeah, cool. So first, just help our listeners get to know you a little bit. How did you get interested in plant science and controlled environment agriculture?
Oh my gosh. I may be a little bit older than your listener, so that's a long story. But I think it really started out that I was just interested in photosynthesis in general. So I was really interested in the biochemistry of photosynthesis. That's what I got my master's on. And I mean, let's face it, that is the miracle that allows all of us to live. And just understanding that at a biochemical molecular level was what drove me initially to start studying plants as well as photosynthetic bacteria. So understanding those processes, and so I got my master's at the University of South Carolina, and then I came to Davis, which is, one of the epicenters of plant biology research, and did my research here in plant molecular biology, really examining ways to move genes into plants. If we can think about that long ago, there was a time where we didn't even have the tools, let alone CRISPR, we didn't have the tools to really be able to transform plants in the way that we can now. So we were doing that. And you got to a point where we could really understand how we could make plants work for us even more than they already do. So I did that and started to then look at the relationships between microbes and plants. So at Stanford, I initially did a postdoc for about 4 years where I examined the relationship between alfalfa and rhizobium.
Okay.
And stayed at Stanford, again, for a long, long time, as you mentioned, teaching and also doing research. I looked at pathology of Eustalogomatus in corn. And then actually, I was really privileged because a friend of mine actually started the LED lighting company LumiGrow, which, unfortunately now is folded. But it was really ahead of its time, I think, in that was a time where I can remember talking to my friends at Philips, and they're like, we're never going to do LEDs. They're just, a little entertaining kind of cute thing that's kind of fun. And of course now, most growers, are really using LEDs aggressively. So it was a privilege to be part of that initial part of the acceptance and driving that acceptance and also driving some of the understanding of spectrum. Even though I think we're not really using it in the field that much, there's a lot of awareness of how we can use different spectrum to get different phenotypes from the plants. So, and then, again, it was fun the last 3.5 years to work for Plenty, working at a company that's really driving production in a new way at a new level. So, yeah, that's my life story.
That was really succinct. I'm really impressed, to be perfectly honest. So, what was the spark that initiated LumiGrow? And was it always intended to apply LEDs to commercial production of plants, of crops?
Yeah, absolutely. Kevin Wells is the founder. He remains a really good friend of mine. In fact, he's going to be working closely with me at my consulting company, Grow Big. And Kevin is a mathematician, technologist by training. And he tells the story almost like, driving down the road and passing multiple greenhouses and just thinking about the wasted energy, the light that was escaping from those greenhouses. He understood the inefficiency of high pressure sodium lighting. And he just said, I can do better. And I think that at the time, I'm kind of smiling because at the time there was starting to be more and more LEDs being used at the festival Burning Man.
Oh.
So Kevin participated at Burning Man, and there were friends that were using LEDs for different, art projects, things like that. But there was this really, synergistic thing that happened where, the blue LED became available. And of course, there's the famous Nobel Prize that was won for that research. And so once we had the red LED, which had been around for a long time, and then we had the blue LED, and then subsequently other spectrum colors of LEDs available, we could really then start to think about what plants needed.
So was he going to Burning Man and seeing them for art, the use of LEDs for art installations before LumiGrow?
I would say yes.
Okay.
Yes, he was.
Okay.
Yeah.
And so the blue light, the blue LED was developed before LEDs really became practical and useful in a commercial setting?
Absolutely. Yeah, I should have looked up the exact dates, but we can do that easily.
Yeah.
But yeah, the red LEDs came out. I mean, most of us can kind of remember, clocks or digital watches, and, red LEDs were pretty prevalent. And I think there was some unfortunate things that happened where red LEDs were used by some growers, and some growers were encouraged, like, hey, you can use this red light. And really, if you use red light alone, you end up with a pretty sad-looking plant.
Yeah.
It's all stretched out and ugly, and, it's just not happy. And so people got turned off by LEDs in general. And that was a barrier that LumiGrow had to kind of cross over to kind of say, no, wait, these are not the LEDs of yesteryear. These now have this blue light, which we can add a more balanced approach. And of course, now with the green diodes available, that can even be more balanced and more tuned to plants. And we're hearing a lot more about, far red being added to the spectrum portfolio. And that's giving a different power to LEDs. So it's really grown leaps and bounds just in the last 10 years.
Yeah, a lot. And I mean, when I just even think about the early days of using LEDs, the early days, I think of NASA, right? And trying to find a way to grow plants in space and use it, they have very constrained space requirements. And so, like being able to put lamps as close to plants as possible was definitely a benefit. And also not having, mercury and high pressure sodium exploding in space, right? Like that's a really bad thing to happen. When it comes to like the commercial adoption of LEDs, you mentioned one of the barriers being that the early people who tried using LEDs saw these stretched out plants. I mean, over the last 10 years, we still hear people who think that LEDs can't grow plants as well as high pressure sodium lamps or the sun. I mean, do you think that's true? Are we still on a path of trying to figure out how to use LEDs most effectively to grow plants? Is the sun still the best source of light? You're shaking your head.
Yeah, I'm shaking my head. No, absolutely not. We have an emotional attachment to the sun. I mean, rightfully so. Again, our life depends on it. So, and it's so romantic to think about, the plants respond to the spectrum from the sun is the perfect thing. But we kind of know intuitively that's not true. I mean, we're all susceptible to sunburn, for example. So too much sun is a bad thing for any living thing. I'm just kind of using that as an example that the sun's just not this most wonderful thing in the world. There's quite a few people that have done studies where we ask the question, I did this experiment as well, ask the question with lettuces, if having a gradual ramping up to the light would be a better way to grow plants. So gradual ramping up.
Like sunrise and sunset type of thing?
Exactly, mimicking that. And what was funny, I was at a dinner with several of the greatest scientists in controlled environment ag, and we were talking about that. And what was so funny was we had all done that experiment and nobody had published it really. Because everybody had gotten a negative result. The lettuces didn't care. They didn't care if you just turn on the lights and say, go to work, guys.
Bad results are good results in
I know,
science.
exactly. But everybody done it, it's like they didn't care.
And was everyone just disappointed that it didn't work out the way that they wanted
it's like,
to?
well, I don't know, because it required, more complicated, like, okay, we're going to give them, what PPFD are you going to give them, for their little sunrise peak. But at the end of the day, adjusting for DLI so that it was all the same. And this is work also, actually, there has been a little bit of work that has been published, tolerance for, not inconsistency, but, this tolerance for different DLIs.
Yeah.
And that's how there has been some publications. And actually, plants have Mark Van Ursel and his team have published this work. And there's a much greater tolerance than we had anticipated for this light variation, as long as it ends up the same. And again, I think it's almost like, I think we know this intuitively if you think about energy in, because again, we can think about, the calories we eat, most of it just kind of, eat what we need and we stay the same and we grow. And that's what plants do. They eat what they need and they're able to accommodate that.
So is that one of the potential benefits of LEDs, is that we can give them the amount of light, the amount of photons that are really useful to them, rather than wasting a bunch of other photons that they don't need or can't use?
That is one of the real benefits. And one of the benefits that we explored a lot at Plenty is you can give them more photons than you think they need. We can fatten them up, like a duck.
With more photons?
Well, if you think about, traditionally, for example, lettuces have been considered sort of a low light plant. And yes, you can get a lovely crop at a pretty low light level. But, what we learned at Plenty, if you want to be aggressive and get high yields day after day after day, you can give these plants a very high level of light. So we usually gave between 600 and 800 micromoles of light, which is not
for lettuce.
For lettuce, exactly, for lettuce. Wow. So that's, relatively unheard of, but that's now standard at Plenty.
Interesting.
And, with some of the lettuces, we can even push a 24-hour photo period.
I was wondering about that. I feel like there's some debate about whether lettuce plants need a resting period or not. You guys found that not necessarily?
Well, I think you're hitting on another topic that we can talk about later, because I feel like it's a little bit relates to what research should be done at companies and what research could and should be done at universities. I think that the photo period can be relatively species, certainly variety specific, and you have to examine that. So, you might have a romaine lettuce and it's pretty happy at 24 hours, but another leafy green, certainly a kale or a spinach, may not perform that way, and even some of the other lettuces will not perform that way. So you have to examine that.
Well, I mean, kale, I think of kale as being sort of a fall or winter crop, and I imagine maybe that has something not just to do with the temperature of the air, but also perhaps the amount of light that's available.
That's true. That's true. Yeah, absolutely.
So when you talk about the amount of light and sort of plumping up our lettuce plants and increasing the intensity, is it increasing the DLI, like the instantaneous intensity, or can you do the same thing by growing the plant longer and still accumulating over time the same number of photons?
Yeah, so there's a couple of papers, and I actually repeated this research and did some nice research with Jake Hawley on this, that I'm smiling because I kind of would say, like, low and slow is the way to go.
Okay.
So if you have the luxury of getting that high DLI, getting that DLI of, let's say 40 into a 24-hour photo period, and it's lower than, giving, again, I don't know the numbers off the top of my head, but, having a 12-hour photo period, 18-hour photo period at a higher level, you conceivably, and data has shown that you will get a better yield. So again, another little thing I say to make it resonate with people is, if you eat a 2,000 calorie Thanksgiving meal, you just kind of feel bad. But if over the course of a day you eat 10, 200 calorie little snacks, you feel better and you digest better.
Yeah.
So that's the way, again, I kind of like break things down.
I like that.
To how I can visualize them. But pushing them as hard as you can for as long as you can is, again, what what the research at Plenty has yielded for us, and pushing harder than you think you can. The backside of that push is, if you're making a living thing run as fast as it can, you have to take care of all its other needs.
Yeah.
So that's the tricky thing.
You can't just push the gas pedal on one variable. You have to do something with the tires and the brakes and the engine and everything. Yeah.
Yes, absolutely. Yeah. No, you said it very well. Yeah, you've got to manage that root zone, that fertigation, that airflow, that temperature. You've got to get all those variables right.
Yeah. I want to talk about spectrum for just a minute, and even its relationship to efficiency and plant growth. So we talked about red and blue, and now there's green, and now we see full spectrum, right, lamps. There's a lot of research, fundamental plant science research that we see being done with looking at tunable LEDs, hitting these specific spectrums and ratios of spectrums of light for different species of plants. Something I always wonder is, if we find a magic ratio, and that magic ratio is different for 5 different species of leafy greens, and I'm going to grow those 5 species of leafy greens in my vertical farm operation, is it practical and realistic to design my vertical farm facility to have 5 different ratios of spectrums of light for those 5 species? Or in the end, am I just going to pick one spectrum or one type of light that can sort of serve all their needs, right? In an okay way, right? So I'm not doing anything specific for any species, but I'm kind of finding a more broad range spectrum that fits them all. I just want to ask you about the practicality, I guess, of some of this research that we're doing on light spectrum, and if in the end growers are just going to pick a full spectrum light anyway.
Right. Yeah. So you're asking a really excellent question, and it's, do we appeal to the practical or to what you might love? So I love spectrum. I really love spectrum. I also love driving a standard transmission car, but in the last few years, I drive an automatic transmission. Can you get better gas mileage with a standard transmission? Yes, you can. It makes it easier to rent a car in Europe.
Yeah.
but is it really worth it? And again, it's like car company. I mean, to me, that's kind of a good comparison, because yes, you can eke out a little bit better flavor, maybe a little bit better nutrition by getting the spectrum exactly right. The question really for growers is, what will your customers pay for? And people that are outside the realm of being super tasters, can they even taste that difference that maybe some people can? And I think that's been, one of the real questions. So a lot of the spectrums that several of the lighting companies are providing, they're just really good basic spectrums for a broad range of plants. And could we get more out of having adjustable spectrum? Absolutely. But I think that it's really dependent on having a high value crop. And this is where it gets interesting, where, strawberries are being grown by some of the farms now. Is there a crop that is of a high enough value that requires that special taste, that, the aroma, the sweetness, the bricks of a strawberry, that somebody might pay for, that warrants that spectrum that's really dialed in? So I think that, we'll see a lot to come in the research associated with spectrum, but I think we're also in a good place right now with the lights that people are providing for a lot of different plants. Okay.
So going back to, I made the comment about efficiency. In California, I'm sure you are aware, being a Californian, that we have a new energy code that targets controlled environment horticultural lighting, and efficacy of that lighting for both indoor and greenhouse. I'm kind of curious, just your thoughts on that new code, and also, how are we making LEDs more efficient? Do you know the answer to that question?
Well, let's see. Yeah, we'll have to get my friend Kevin Wells in to do a
sure.
podcast because, I'm not an engineer. What I have been told by, the engineers is we've seen this rapid, wonderful decline in the price of LEDs and the rise in efficiency. And, that's just been fantastic. So, the cost of LED lights have been, dropping and makes it more affordable for farmers. But I've also been told absolutely that there's a limit to how efficient you can make these lights.
I have to believe that.
Yeah, exactly. It's just like, it's physics, not magic. So, and then we're almost there. We're almost to...
You think so?
That's what the engineers tell me, that we're almost there. We can't make them a lot more. So the gains that we've realized recently have been the easy ones, the low-hanging fruit. And so there'll be maybe incremental little gains in efficiency, but it's just not possible to...
Is there a trade-off between efficient lighting and plant yield or quality?
Efficient lighting.
So I guess micromoles per joule. Like if it gets more efficient, does that necessarily mean that the yield will be less or more, or that the quality will be less or more?
No, not really. I mean, I don't think of it that way. I mean, I think of it as, the plants are eating energy. They're eating the photon.
Okay.
So they don't care if you have to work really hard to put that photon in front of them, or, so if it's very difficult, so I'm saying if the diode has a low efficiency, or if it's a high efficiency. To them, a photon's a photon.
Okay.
So that's their, that's their lunch.
Okay.
So the efficiency doesn't make a difference to the plant.
While we're talking about efficiency, what do you think are some other low-hanging fruit or some other parameters, plant growth parameters, that could improve the efficiency, maybe the energy or water efficiency of an indoor plant facility?
Well, I mean, I think that, again, we fixated on light because we know that's the energy, sucking thing.
Yeah. The energy succubus.
Yeah, exactly. And then, people talk about labor. I think, that's driven, the excitement around robotics and what's possible there. And that's, still really at its infancy and being explored. But I think here in California, despite this year, water is what we all fixate on. Looking at the efficiencies of water is really the next big question that it has been examined a little bit. I want to say it was examined more 10 years ago. If you look at the papers, there was kind of an explosion of papers looking at drought resistance, mostly around field crops, and looking at that, crop that was going to be drought resistant. But it wasn't really translated or considered when growing hydroponically in CEA as much.
Because plants are always exposed to water? Is that why?
People are, yes. In NFT or deep water culture of the lettuces, certainly, yes.
Okay.
They're always exposed to water. And one question is that absolutely necessary? I think that the high Y growers, the peppers, cucumbers, tomatoes, they are considering this more carefully. Not so much from a water conservation strategy, but more from a, directing and steering their crop, from its reproductive to its vegetative state, back and forth. So how they want to steer that crop. So I think we've got to learn from how our, people about that steer, can we steer our lettuces? Can we, think about water conservation?
Interesting. Yeah, I feel like when we talk about steering plants, we're thinking more about cucumbers, peppers, and tomatoes, or cannabis, and not so much about leafy greens.
Right. You don't think about steering them because they just...
What do we need to steer with the leafy green?
Right. Yeah. We need to steer. It's a short-term crop. You just and of course you don't want it to flower or anything. You just want to make a big, nice green blob, and you harvest it and go home. But I think that what we can do is not so much steering the growth, although I think that is a thing that you can do, because we certainly know, probably most of us know from our home gardens or our backyard gardens, that we didn't water enough. The edge plants may be, compromised and smaller. So we can steer a plant with water. We can also really define the water that's absolutely required. Yeah. And I think that's where we have not done a good job. And again, Mark Van Ursel did studies on this quite a while ago, showing sort of the need is usually much lower than the actual what we're supplying, what a grower will typically supply to get the same yield. Yeah. So, so that's kind of something that I think is fascinating in researchers.
Is water and energy use efficiency, are they mutually exclusive? Are they in conflict with each other? Or could we have both together from your perspective?
I think we can have both together, absolutely. Yeah. Because, I mean, every time you deliver a drop of water, that means somewhere back of the line, a pump's going on, lots of things are turning on to deliver that water. So, it's using energy. Maybe not as much as the lights, and maybe certainly not as much as the lights. So that's why it's been kind of, disregarded. But it's still a fair amount of energy. I gave a talk last summer about this, just looking at the energy associated with Plenty's Compton farm. And it was, like in the $100,000 range of energy savings if you turned off the pumps for 3 hours, like during the SCOTA period at night for the plants. So yeah, it adds up.
Wow.
It adds up.
That's not insignificant.
Right. So it's
interesting.
Like, do what your mother says when she said, turn off that light.
As someone who understands plants at the molecular level, I mean, you have this unique experience, right, where you've done both academic research on plants and you've been at the commercial production or commercial application of growing plants. How do you step back and think about plants at the macro level? Like, you know them so intimately at this micro level. I see your wheels turning there. Because that is not an easy transition to make, I would imagine.
It's not an easy transition to make, but I think this is where, nobody does this work in a vacuum. And it's very difficult to think that you can. So I'm a big proponent of collaborations, whether it's companies or universities. There needs to be more collaboration and working together. And really what you're saying, and again, I'm a teacher for a long time, so I always use analogies that are easier to grasp. But, it's like that general practitioner, the doctor you go to all the time, whatever. And then there's that, heart transplant surgeon or something who has very specific knowledge. But they still need to have knowledge of each other's skills. So the general practitioner needs to know when they need to call in that heart surgeon, the cardiologist, to help out. And the cardiologist needs to know enough general physiology to be able to know, how to do the surgery on their patient. So there needs to be this really good communication and understanding in both directions. You can't just be the grower that you need to be without really understanding more underlying physiology.
I mean,
and vice versa.
Right.
Yeah.
I mean, so you've touched on this in a couple of your answers, but how do we improve collaboration between academia and industry? Or do we have good collaboration, do you think?
I think that it's really changing in the last 10 years. I feel like, I'm seeing it happen more and more and more. I think that it's newer to biology, I will say. I think in engineering, there's been more collaboration in years past.
Oh, interesting.
Yeah. So, when you think about the development of, semiconductors and computers and things like that, I think there was more collaboration. So it's newer to biologies. So I don't think we're there. But let me just sort of speak. So some years I've had the privilege of being a reviewer for USDA grants. And now there's been a real emphasis and call for, what are the outcomes? What is the impact? How is the work going to be disseminated to the public? That's a big part of a grant right now.
Nice.
So it's not just the science and how great the science is, but how does that science get out of the, academic journal into the hands of the public? And, what is the researcher going to do to ensure that? Mm-hmm. So I see that as a big component of whether or not a grant is funded. I also see a little bit, it's just starting to happen, I'd like to see it more, where the PIs on the grants are actually companies themselves. So I think it requires companies to be a little bit more open hand in terms of how they think about the intellectual property, and to say, where can we collaborate? Where's that opportunity? Yeah, and I mentioned it earlier, like photo period. So, does every single company need to build a giant research facility? And that's just, it's just counterproductive.
Right. Literally.
Yeah, exactly. Literally stops the plants from producing. Absolutely. Yeah. And so it's like, this is just craziness. When we've got, we as taxpayers are paying for, down the road at UC Davis, I don't know how many growth chambers they have now, but last I asked it's about 170 or 80, you know. So those should be working for the public because, our tax dollars paid for that. So the fact that Plenty has a facility with, 40 or 50 growth chambers in Wyoming doing research, what if that is duplicating and what if it could be done collaboratively?
Yeah. I've talked to other indoor growers about collaborating with universities and academic research, and I have found it sort of odd and interesting that they will say, oh yeah, we know about that research, right? And we tried that at our facility. And then I'll ask, oh, did you have the same findings, right? Because you're trying to duplicate that research. And they'll say, well, sometimes yes and sometimes no. And then my follow-up question is, okay, did you go back to that academic researcher, the person who inspired you to do this research, right, or the group or the team or whatever, and tell them what you found? And the answer is almost always no. So it's like even just a one-way collaboration. It's not even collaboration. It's just one way that information is flowing without true communication and collaboration on, hey, we found something different. Can you try to duplicate what we found different, right? Or why do you think we got different results than what you did, right? What did we do differently? Like it always seems like the industry is willing to take but not give back. I don't know if that's a good or a bad thing necessarily, but I just find it's just one-sided in a lot of cases when I've talked to people. And I'm just curious, like what is it a real or is it a perceived barrier that industry has to not you said open hand, right? To truly collaborate and work with academic research?
Yeah, so I think you're asking a couple of good questions embedded in that. One of them is, the challenges of scaling.
Yeah.
So scaling is, a big thing to tackle. So small does not always translate to big as easily as we think it should.
Sure.
And I think that's it's an interesting problem. It's one that companies like Genentech have had to face, in their drug production. So we have to look to industries like that. Like, how do you effectively scale? We've learned a lot, and we probably should learn more from the field farmers, in terms of how they've had to scale into large farms.
Yeah, good point.
But yeah, so an experiment that might be done, at a very small benchtop level at a university may not scale into a production farm.
Good point.
And rather than just throw our hands up and go, well, I don't know why that happened.
Oh,
well, yeah. Guess it didn't work. We got to do better than that. And I think, one of the things that's exciting for me is, Ohio State, under the direction of Cherry Kubota, she's recently has now a production-sized greenhouse there. And that's really the first one, maybe only one I know about in the United States that is a publicly funded, available university facility that's at that large of scale. I think it's 2,000 square feet, correct me if I'm wrong. But it's a pretty nice greenhouse where she can start to do experiments at scale so that research can be translated readily into the farmer's hands. I think that this is where, again, we need to be pushing our ag universities, our land-grant universities, to have facilities for our researchers to do these experiments at scale, to do them at the light levels, to do them at the production levels that are needed by the farmers, so it can be believed.
Yeah.
And it can't get lost in translation, so to speak. So, and I think another thing that you're saying that's really interesting is, whereas the academic side, they, part and parcel to being an academic is presenting, publishing results. That tradition has not typically been manifested in companies. So that was one of the things that, I pushed really hard on at Plenty. It's like, we have to give back. We have to have abstracts. And again, it is perceived sometimes within a company as taking time away from something else.
Okay.
If someone's going to go to a meeting and present, they could be at the bench working. But it's just part of being the community that's going to push this information forward. And I think that companies have to change that. You have to publish, you have to present, you have to give back that data. And, again, I act a little bit more like academicians in, hey, I repeated your work and it didn't work for me. Let's talk about it.
Yeah. And what we need at scale, perhaps.
Exactly, yeah.
I mean, what research does industry want? What research does industry need that isn't being fulfilled or focused on that you know of, at least at the academic research level?
Well, again, we've alluded to some of them already. Understanding specific light levels is really important. How much can you push a plant? I think understanding those photoperiod that we've already mentioned too, mm-hmm. Understanding that exact photoperiod. Breeding, breeding's a long game, but that's another big one right now that, most everything has been bred for the fields, and it's coming along. I mean, there's companies like Unfold that are, pushing this, and other companies as well, but breeding for CEA.
Keep going, because I want to ask a question about breeding. Keep going.
Yeah, so I think those are things that universities can do, and
that water research, back up.
Yeah, the water research. Yeah, again, we've kind of figured out a way to grow plants. Is it really the best way? Mm-hmm. Looking at intermittent watering, looking at other water saving strategies. Another big one that we haven't touched on is the nutrient portfolios. Looking at the mass balance approach. So looking at what you're giving a plant and what it's putting in its tissue that you're selling. And what most farmers do is they just, create a mix of all the nutrients that a plant needs, and they sort of assume it's going to take what it needs, and then we try to rebalance that effluent that comes back as best we can, but that's tricky. That's hard because it takes different amounts of different chemicals, and then you have to do the math and think about it and replenish.
Math is hard.
Math is hard. And then you get into the micronutrients, which get kind of increasingly concentrated. Yeah. And they just need little bits of them. And then at some point, almost every grower just throws up their hands and goes, I'm just going to dump this and start over. And the dumping and starting over is something we really need to avoid.
Yeah. Even using reverse osmosis on tap water, right, that's coming from the city to start from zero because we can't do the math, or we're too lazy to do the math to figure out the water already has these constituents in it. We just need to make adjustments. And instead, growers will just say, nope, I just want to start from zero so I don't have to think about it, right? And go from there.
Right. And investing in the equipment so they can, get reverse osmosis, they can repurify their water and get back to crystal clear, wonderful water to start with. They have to do that. And, you talk about, regulations. Those are the kind of things where, a farm may eventually just have to do that.
I thought we had nutrients figured out.
Well, everybody...
I mean, there's so many mixes on the market. One of those has to be the right one, right?
Everybody says that. And, looking to the Dutch and learning from them, I think they may have it figured out a little bit better than we have.
Why?
Because they're constrained. It's a small country compared to the United States, and we have the luxury of having, tremendous resources. And sometimes when you have tremendous resources, you're not as careful with them.
Yeah, of course.
And so I think the Dutch have had to think really carefully about how they manage water and nutrients for a longer time than we have. But it's coming. I mean, it's now. So we have to manage nutrients and understand that. And again, this was something that was studied. I mean, if you look at, the research done by Hoagland, back in the 30s or late 20s or something like that. I don't know,
of the 1900s.
Yes, exactly. 100 years ago, we are fundamentally using the same nutrient recipes as then. And people got bored with studying nutrients, and people...
Really?
I think so, yeah. You find very few scientists that really understand it now and understand they sort of memorize what they memorized during their intro to hort classes in terms of, phosphorus depletion or something. But most people don't really recognize phenotypes of their plants with nutrient deficiencies as well as they should. And I think understanding nutrients, understanding the impact, but again, from this mass balance approach and being able to rebalance that water, or like you say, worst comes to worst, you got to do the work and repurify it.
Yeah.
I think is something that we need to move towards.
Yeah, I mean, fertilizers are a limited resource, and with what, the war that's happening in Ukraine and right, like we have a depleted resource of some of these elemental, right, fertilizer chemicals that would normally come from Russia or from Ukraine. And so we are seeing restrictions, right? The prices are increasing. I mean, it's sad to think that that's what's going to drive better nutrient resource management, but I think it does at least put in our consciousness here, especially in the U.S. and North America, that this is a limited resource, that we don't have unfettered access to all the chemicals in the world to grow these plants.
Right. And you mentioned, too, they are expensive. I mean, again, they don't feel like the most expensive thing, like the lights. But when you start to do the math, at a Compton-sized farm, they're a lot. And we used to think carefully about, which chelate we might use, because one's more expensive than the other. All these things become a question. And it's interesting how, again, they add up quickly. And if you can rebalance and not just waste them, that's really, really important.
Well, and then, I love that you use the term mass balance. As an engineer, I think about energy and mass balance all the time. But the other thing that kind of comes to my mind when you say that, and we've been talking about the different gas pedals and brakes that we have with lighting and temperature and airflow and water and nutrients. I mean, if we change the intensity, right? So if we decide to push these lettuce plants really hard, does that mean that we also need to increase the nutrient concentration available to them? Or could we continue to use the same recipe we did under a lower light intensity? Or anything, a high temperature, low temperature, right? Like all these variables are so intertwined with each other.
They are intertwined. Yes, absolutely. I wouldn't say more necessarily, but balanced. Because again, the plant's getting its energy from the light. So that's its calories, if you will. I'm switching to not the car, the person. So it's like the athlete, they may need more calories, but they're getting that from the light. But you want to make sure they're not iron deficient, so to speak. They're not using more iron because necessarily, yes, they are using more iron if they're going to get bigger, but it's a constant growth. You don't feed them more iron for that moment. Okay. If that makes any sense. It's more like that steady availability of the elements that they need. Okay. So yeah, it's not a variation really at all of the elements. But that said, I think there is some information that we don't know about. I think there's stuff we don't know about. This is
why you said this is a research need.
Yeah, exactly. Because, again, if we had that ability to push and pull, giving this light, maybe this light with this spectrum with more, phosphorus or nitrogen at a specific time during development, again, that's another area of research that there has been some nice research. Kelly Walters did some nice research out of this at Michigan State, looking at early plant development, looking at that seedling development and its impact on a plant later in life. Again, we know this.
Yes.
If you feed kindergartners breakfast, then they do better. So,
assuming any unfed elementary school students. Sorry.
Well, they've done studies on that. It's like so.
A news story of the moment. Sorry.
Oh, okay.
Maybe you haven't heard that.
No, I haven't heard that.
We'll talk about that.
That sounds
later.
scary. But plants are the same. They how they develop in that first period of life and how they're fed and nourished has impact on
even drought tolerance. That's been something that I've been interested in a long time, is water use efficiency and drought tolerance in plants. That was part of my PhD research, and that you can sort of train a plant to use less water, to be drought tolerant if you start them by, withholding some water. If you don't just give them all the water they need from the beginning, then they learn to be drought tolerant and need less later. Yeah. And, in cannabis, there's a lot of discussion and conversations and practices around nitrogen depletion at the end of the flowering cycle. And if that has any benefits to maybe I think what it is inducing a stress response that causes the flowers to be either bigger or to have higher terpene content, but depleting that nitrogen to force a stress response, I think.
Yeah, that's an interesting question. I know a lot of cannabis growers like to do a week-long or 2-week-long water flush, where they take away all the nutrients and ask their plants just to be clean, clean, clean.
Yeah.
So
what do you think about that?
It's a stress on the plant.
Yeah.
But, when you stress a plant, it usually decides to reproduce, which means it puts more energy into its flowering and reproduction. So from a cannabis strategy, I think it's probably a good one.
Yeah, nice. I just wanted to come back to breeding for a second because, traditionally, like you said, breeding has been done for field crops and it's for yield and disease resistance, right? For CEA, if theoretically we don't have any diseases, I know we have diseases, but let's just say, right, like we're able to manage them. And maybe the root zone is a little different, but, we have UV and we have ozone, right? Like we can do things to clean the water and help the roots. And in the air, we have filters, right, that we can filter out and protect our crops from molds, right, mold spores and things like that. I mean, for indoor farming, are we breeding for those same two variables like we do for field crops where it's yield and disease resistance, or is there a different variable if disease resistance isn't as critical? And maybe I'm speaking out of turn, maybe it is. What's the other variables that we would be breeding crops for?
Well, I didn't tell you to ask that question, but I'm really glad you did.
Oh, good.
Because that is what is so exciting, Nadia. What you can breed for is flavor and nutrition. I mean, we can just make flavor the key thing that we all think about. And I just think that we have gotten complacent in accepting a tomato that's, it's okay.
Right.
Or a strawberry that, well, if you put a little sugar on it, it's okay.
Throw more whipped cream on top.
Exactly. So I think that we can grow for flavor, and we can also grow things that we didn't grow before. So, I used to say, like cloudberries, which are grown like north of the Arctic Circle or something like that. Things that we don't see in the grocery stores even now, things that were just left on the cutting room floor. We can grow fun things because we don't face that disease pressure, and we can really control the environment. And that's what's just really thrilling about controlled environment ag. You can control it. So, I think that, you mentioned disease. Disease should not be a factor if the farm is managed right. And I think, a lot of farms more and more, if you grow into a controlled environment ag facility, you gown up almost like in a silicon chip factory where, you change clothes, hair nets, it's positive air pressure. That place is clean. So, yes, biology is biology. Disease will always work its way in, but I think that we can disregard that as the major component that we have to think about, and think about flavor and increase number of species that can be grown and offered to people to get people thinking about eating more fruits and vegetables, less processed food, and just being healthier in general.
Yeah, I love that. That's pretty exciting to be able to eliminate disease as one of these factors we're breeding for, and to think of it more about quality. So that quality and yield, I feel like quality and yield, that there's always trade-offs for one for the other. That a lot of times to increase the yield, you are decreasing the flavor profile or something about the quality characteristic of that plant, and vice versa. If we really focus on quality, we might not get the same yield. And so the idea that we can breed for flavor and yield together is very exciting.
Yeah, I think it's just an incredible future that we're facing with controlled environment ag.
Yeah. That's a really good segue for my next question. I guess the way I want to ask it is there anything the Stanford approach to education and research and just developing young minds, I guess, is there anything about that approach that can teach us about this grand startup that we call indoor agriculture?
I think that we need to make people aware that if you hate growing plants and really aren't interested in getting your hands dirty at all, there's a place for you in controlled environment ag. That it is a field that is requiring every smart, capable person we have. So if you are a data scientist or a computer engineer, or if you are
a mechanical
engineer, yes. So it's not CEA is not ag the way we think about it. And it's requiring just all of us to contribute. So that's one thing I want students to think about. I think that the other thing is there needs to be this balance in education that, and you asked about the Stanford approach, there's sometimes this way we teach students where we say, you need to know these things and you'll make an A in the class. My approach when I taught at Stanford was like, you need to know these things to be able to think critically and solve the problems. So the tests were never about, regurgitating memorization. It was using that knowledge to design something, to think about something. How do you approach a problem? We need to get students to think about, how do you solve a problem? Yeah, you have to memorize the elements that a plant uses. That's a given, but that's not what I test you on. I don't test you on what level of nitrogen you need. I test you on, how are you going to create a system to do the mass balance?
Nice. Yeah, because we don't know how much it needs.
Right.
According to you a few minutes ago.
So I think, that's where we need to, and, so attracting kids from all different fields and getting them excited about the challenges, the really hard problems, and also convincing people that, I'm a little bit biased, but, this is the most important thing that anybody could do, I would almost say.
Really?
In my little bias. Absolutely. I just think that, eating is so fundamental to all of us that a lot of people, when they think about careers, they think about, being a doctor or lawyer, mostly doctors, for my students at Stanford, but they neglect the fact that, feeding people healthy food is really what we need to be doing. And if we can do that, we might need a few less doctors.
Exactly. That's a very good point. I also like that, this idea of critical thinking and problem solving. And earlier you said, there's things that we could even learn from field farmers. And I think that's one of the skills that we can learn from field farmers. One of the first things that I fell in love with farming when I worked on that mushroom farm in Idaho 25 years ago now, was that critical thinking and problem solving and wearing of multiple hats. The farmer was not just growing mushrooms, right, and mixing, substrate to grow these mushrooms and then sell them. He was also, the technician, right? He was also fixing the tractor, fixing the machinery. He was, buying the environmental control systems and making adjustments to the temperature and humidity. He just wore so many hats that I was like, wow, it was just so impressive how many things a farmer does, right? And they could be out in the middle of a cornfield, right, that's 100 acres large, and their tractor breaks down. They're going to fix it right there. They have to, right? Like, that is their livelihood. And so I love that is something that you can also learn at Stanford, right? Or in higher education, that's something we should be teaching our students, is to be a farmer in a way. Be able to think through those problems in unique and in different ways, because that's what this industry needs. We don't have it all figured out. So having more critical thinkers to figure it out, is a necessity.
Absolutely. Yeah. No, that's what we need.
Yeah. So I want to ask you, why did you name your consultancy Grow Big CEA?
Well, it actually, it's one of those things, I think a lot of companies, have pretty intriguing names that are, you wonder where they came, those, was that Latin or Greek or something or something like that?
A lot of times it is.
Yeah, so I was actually sort of, falling asleep in that time between, wake and sleep, things come to you, because I was looking at all these more complex names, and I was thinking about you, Nadia, Dr. Greenhouse, and good friend of mine, Paul Fisher at University of Florida. He has Plant Doctor, I think.
Yep.
And, so I didn't want to be another doctor, but a very dear friend of mine, he has a really nice company that they do therapeutics, and his company is called Good Therapeutics, doing really nice work with cancer biology. And it just came to me, what do we want to do? We want to grow big. We want to grow big plants. We want to grow healthy plants. We want companies to be successful. We want to help companies succeed. We want to help people grow big, just grow big and healthy. So it just kind of came to me as simple, easy to remember.
It is.
And it's really geared around a service, almost analogous to being an extension agent. Is I think people that reach out to me is, they're reaching out to me, but I'm reaching out to, for example, you. If I don't know the answer from let's say an HVAC standpoint, I will pick up the phone and connect you with Nadia, connect you with the people that know even more than I do. Mm-hmm. So that's what I really want to do is help growers make these connections so they can succeed.
I love that. So simple, easy to remember. What would you say is your specialty? If a grower wanted to contact you for consultancy, like where do you feel like you can help the most?
Certainly my years at Lumigrow, I have a great depth in lighting. So, and then my years at Plenty really diversified that knowledge skill from lighting to production in general. So, what I experienced at Plenty, when I joined them, we had not yet initiated the Compton farm, which for those of your listeners that don't know, that's a large farm that's just been completed. It'll supply about 450 grocery stores in the greater Los Angeles area. So I was part of that scaling consideration, the engineering decisions that were associated with that. And we had a production farm in San Francisco, South San Francisco, as a prototype to understand how we could scale. So I think I'm good at that transition of small to big. So lighting, small to big, and then general plant physiology. Plenty was working on strawberries and tomatoes and other crops. So, I have a working knowledge of those. In my work at Lumigrow, I worked with a lot of diverse growers in terms of the steering and making sure the light was being utilized effectively. So,
yeah. You wear many hats or have worn many hats. I mean, if somebody wanted to incorporate an R&D space in their facility, in their farm, is that something that you could help them develop as well? Like what to think about in terms of the R&D space versus the commercial production space?
Yeah, I would love to do that. Yeah, I think that would be really fun for me and exciting, because what I'd like to do is help them discern what research do they absolutely have to do. We've talked a little bit about, what could and should be done at the universities, but there is some that you just have to do yourself. So I'd love to say, okay, you're going to need this much space for the research you're just going to have to do with your particular varieties.
Yeah. Nobody ever complains about too much space.
Yeah, but giving space up to research is always like, wait, that could be production space.
True that. How do you predict or hope the industry is going to evolve over the next 5 to 10 years?
Again, we've touched on some of this. I really want to see this, close partnerships between universities and industry. I want to see the grant money spent in an effective way so it gets in the hands of people. I want to see new crops. I want to see new species being grown in CEA. And I think the last one is I want to see, there was just one other thing that I wanted. I just can't think of it right now. Sorry.
That's okay. All right, so last question. What do plants crave?
Oh my goodness. Plants crave what we all crave. They crave being at the right temperature, being warm and cozy, just like the right temperature. They crave like having the right amount of food when they need it. Everything's right there when they need it. And they crave being safe. They're not being blown around or beaten up too much by the environment. So again, like any living creature, think about yourself, think about your dog, your cat. That's what they crave. They crave being nurtured and cared for.
Nice. And
then they'll grow for you. They want to grow. Plants want to grow.
That's what they're in the business of doing.
Yeah.
I mean, yeah. And we wouldn't be here without them, for sure.
Absolutely.
Yeah. So I have just a few rapid fire questions. And basically, I just want you to answer in 1 or 2 sentences or a word. If you want to expand on anything, please do. But they're meant to be short. All right. You ready? Are plants introverts or extroverts?
Extroverts. They're always curious.
They're always curious.
Yeah.
What are they curious about?
Oh, they're reaching for the light. Their roots are reaching for the nutrients. They're looking for the water. They're just like out there.
That's an awesome answer. What have plants taught you?
Oh my gosh. Plants, every time I see a seed germinate, I smile. I mean, we are all part of this miracle of life.
Yeah.
And they humble me and I'm in awe. I'm just in awe.
Yeah. If you could research any plant growth parameter, what would it be?
Ooh, the one I want to research, but I'm scared of it because it's so darn hard.
Yeah.
Is beneficial microbes.
Oh.
Yeah, beneficial microbes. That's one of the big next horizons, is microbes that help plants grow or protect plants. And we know it's there, just like we know our intestinal gut bacteria is so important. We understand that it's so important, but do we understand it? No, we really don't understand it very well. So I would love to research that and dig in and say, let's figure this out. And
why do you say it's scary?
It's scary because I think that it's so interconnected. The relationships between the plants and the microbes are so complex and interconnected, and even between different species of microbes within the rhizome area are so complex. So it's a hard question, I guess, and that's why I use your intestines. Most of us, after we take antibiotics, we go and we eat some yogurt or pills that have microbes in them to kind of reboost that intestinal flora, because we don't really understand it.
Yeah.
And then the same is true of plants, and it kind of goes back to when I was studying the relationship between alfalfa and rhizobium and that signaling between the plants, where the plant allows for that infection of the rhizobium to form that nitrogen-fixing nodule. So, it's a game that they're playing, like, hey, do I want to let you come in? Oh, yeah, I do, because you're my friend. Yeah, come on in, and I'm going to make you a anaerobic house, because nitrogen fixation only occurs in an anaerobic environment. So it's just like, I would love to work on beneficial microbes.
Yeah. Plants don't live in a vacuum either.
Yep.
What's one piece of advice you'd give to a new CEA grower?
I would say keep learning.
Okay.
Keep learning, keep reading. Try to always carve out that time for yourself to read, to learn. There's so many online courses now that are available, particularly University of Florida offers some really nice classes in everything, in horticulture, in everything in cost and profitability to growing hydroponically. So keep pushing yourself to stop and learn.
That's good advice. What's the worst advice you've heard or been given about growing plants in CEA?
The worst advice that I've observed in...
Sure.
Oh, gosh. The worst advice is sometimes when you have an infestation, for example, of Pythium, or sometimes people think they can just keep plowing ahead. And I think the worst advice I've ever witnessed is like, no, you have to shut down your farm right now. You have to clean, you have to, because that's a very hard decision. But I've witnessed that a couple times,
Where they didn't stop to clean?
They tried to not stop.
Yeah.
And to come in and say, you have to stop.
Yeah.
You really have to stop.
It's labor intensive. You have downtime. But in the end, I imagine it could actually boost production, right?
Yes, exactly.
Yeah.
It does boost production. So,
okay, hydroponics, aeroponics, aquaponics, or soil?
Oh my goodness.
You can only choose one.
Oh no. Well, if I can only choose one, I have to choose hydroponics.
Okay.
I have to choose hydroponics, but
Is there a rank? You're like shifting. I can't tell.
Well, I think the question that you're really asking is embedded in that is also the accessibility to different growers. So, if I'm in a rural community in the States, or I'm in a rural community in, I don't know, in Africa somewhere, what are my tools that I have available to me to grow?
Nice.
I think that hydroponic growing offers a lot. It offers the control that I really like as going back to my biochemistry, I like control. And it offers an opportunity to really understand what you're doing. Aeroponics, I think, has, it's a beautiful system. It has a lot of promise. I think it's a little bit trickier to get set up for many people. So, and what were the other two? Soil or?
Aquaponics.
Aquaponics. Well, aquaponics, I admire greatly the people that do aquaponics. But, then you're adding literally a whole nother animal. So, that's, a complex, really interesting, exciting system. But I wouldn't start there.
Yeah.
Unless you want to make your life really challenging.
It's complex, for sure.
And soil is beautiful, but again, there's a lot of crazy stuff going on there. Yeah. And I'd like to understand it more before I committed to the soil.
Like those beneficial microbes.
Like the beneficial microbes, and we just talked about the benefits of not having to consider disease resistance as much.
Yeah.
And if you're using unsterilized soil...
That goes out the window.
That goes out the window, yeah.
Well, hopefully there's no windows in your vertical farm, but maybe a skylight, an old skylight. What crop do you want to see grown in CEA in the future?
Oh, my goodness. Like I say, I want almost all of them. All the ones that are sweet and fun to eat is what I want to see. All the berries, maybe I want to see cucumbers. I want to see striped cucumbers. I want to see all kinds of cucumbers. I want to see all kinds of peppers. Again, a pepper, we all know about sweet peppers and spicy peppers and stuff like that. But there's a whole ton of peppers in between.
There's a lot of peppers, yeah.
And cucumbers can be these little round, wonderful things that you just pop in your mouth. So I want to see, even within the crops that we know about, bring back the different varieties that are just crazy fun and beautiful and attractive. So, and then again, the berries too. The berries, they're just a cornucopia of different types of berries that, we've never seen.
Right. And a lot that grow very regionally, even here in the U.S., that you can't get in certain other places of the country. So to be able to even bring those out of those regional pockets and allow the rest of us to experience would be awesome through CEA.
Yeah, exactly. So that's what I want. I want people to see that promise and how exciting that promise is.
Awesome. Well, Melanie, that is all my questions for you. Thank you again for being here live in person. It's really nice to sit across the table from you.
Yeah, thank you, Nadia. This has been a real pleasure for me as well.
Awesome. Well, let's go look at our vertical garden and...
Can we pick some and eat some?
Absolutely. We make really spicy arugula here. Grow, I guess.